Hi everyone, I'm Gunashri studying in Sri Venkateshwara College of Engineering. Today I'll be discussing about the topic dynamic hashing and leftist tree. So moving on to the first topic, that is dynamic hashing in data structures, how it will be easily followed. So what is dynamic hashing? So it is a technique used in data structures that is used to efficiently store and retrieve the data. It is particularly used when dealing with large data sets that may grow or shrink over time. Data dynamic hashing will allow for efficient operations such as insertion, deletion, and searching also. So moving on to the what is hashing basically. So it is a process that will map data to a fixed size of array called a hash table. It will use a hash function to generate an index for each item, ensuring fast access. So the main aim of hash function is to distribute data evenly across the hash table to minimize the collisions that will be occurring during the process. So what is the difference between static and dynamic hashing? So static hashing will use a fixed size hash table, which can lead to collisions and hence efficient space utilization. In static hashing, we cannot input many number of values into the hash table. How many ever values will be specified, only those many values can be put into the hash table. Whereas in dynamic hashing, we can adjust the size of the hash table dynamically to maintain an optimal load factor. So the dynamic hashing will also avoid collisions by redistributing data when the load factor will exceed a threshold value. So what is the structure of a dynamic hash table? So it will consist of an array of buckets, each capable of holding multiple items. Each bucket will has a local depth indicating the number of bits that will be used for hashing. So the hash table will also maintain a global depth that will be used to determining the number of bits for indexing. Moving on to next comparison again between the static hashing and dynamic hashing. So as stated earlier, static hashing is a fixed size form of data, whereas dynamic hashing, it is a variable size of form of data, that is n number of inputs can be taken again and again. Data bucket, so fixed number of data bucket values will be present in static hashing. In dynamic hashing, the data value or the data bucket number will vary dynamically. In static hashing, the challenge of bucket overflow will arise when the amount of data will surpass the available memory, or when we try to input a n number of memory, although the specified memory is allocated. Whereas in dynamic hashing, the bucket flow issue will be overcome effectively. The static hashing will be used with data bases of limited size, whereas dynamic hashing, the databases of large sizes or scalable sizes can be used. Static hashing is less efficient, whereas dynamic hashing is more efficient. Static hashing is simple in its complexity, whereas dynamic hashing is complex in its complexity. What is overflow handling in dynamic hashing? So, for example, when a bucket becomes full, then an overflow condition can occur in dynamic hashing. So, this overflow can be handled by splitting the overflowing bucket into two new buckets. Splitting will involve increasing the global depth and redistributing the items across the new buckets. Moving on to the operations that can be performed in dynamic hashing. First one is the insertion. First, to insert a new element, first we have to check whether the hash function is applied to determine the bucket index or not. If in case the bucket is not full, then the item will be inserted directly into the bucket. If in case the bucket is full, then the bucket will be split and the item into two different buckets, and the item will be inserted into any of the new bucket. The second operation, that is deletion and dynamic hashing. So it will involve locating the item in the hash table using the hash function. Once the particular item that has to be deleted is found, the item will be removed from the respective bucket. And if in case the bucket completely becomes empty after deletion, it will get merged with another bucket to optimize the space usage. So this will be useful for utilizing the space in a more effective manner. The third operation, that is searching in how to search an element in dynamic hashing. So it will involves applying the hash function to determine the bucket index. First, the bucket is searched for the desired item. If in case the item is not found, then the item that we'll be searching for will not be present in the hash table. Moving on to what are the advantages of dynamic hashing. So it will provide efficient insertions, deletions, and searches even with changing data set sizes. It will optimize utilization by dynamically adjusting the hash table sizes. It will also minimize collisions and improves performance compared to static hashing. So these were the few topics discussed from dynamic hashing. So what are the conclusion drawn as it is one of the powerful technique that is used in data structures to handle a very large, enormous data sets and also changing data sets. It will offer efficient operations, optimal space utilization, and minimal collisions for the users. Understanding this dynamic hashing is very crucial for designing scalable and high performance data structures. Moving on to the second topic, that is the leftist tree. So these are the type of binary tree that will maintain a specific property throughout each and every operation. They'll be defined by the structural property rather than balancing constraints, providing unique advantages in various applications. Moving to the definition and properties of leftist tree. Definition basically states that it is a binary tree with leftist property, which state that for every node, the distance of the rightmost leaf is smaller than or equal to the distance to the leftmost leaf. So what is the property of leftist tree? So these trees are binary trees where the null path length of every node will satisfy the leftist property, ensuring a unique structure different from traditional binary trees. Moving on to the leftist tree operations, that is a merge and select. So what is merge option? It in leftist tree, it is mainly essential for maintaining the leftist properties. It is used to combine two leftist trees into one while preserving both the properties of the leftist tree that is merged. Insert option. So inserting a new node into the leftist tree will require adhering to the leftist property. That is, a property should not be lost while inserting an element, and we have to also ensure that the overall structure will remain consistent during the insertion process too. Moving on to the advantages and disadvantages of leftist tree. So leftist trees are efficient for merge operations and it will support a flexible structure, making them adaptable to various scenarios. Disadvantages are they may not offer the same balance guarantees as other trees, potentially leading to suboptimal search performances in specific cases. Where are these leftist trees mainly used? So some of the applications of them are they're widely used in networking, scheduling, and dynamic memory allocation. So in networking, they're used in network optimization algorithms for efficient resource allocation. In scheduling, they're applied in task scheduling systems to manage and prioritize tasks effectively. In dynamic memory allocation, they're utilized in memory allocation systems to optimize memory management in an effective manner. Moving on to the conclusion of the left history, this will offer a unique structural advantage and efficient operations, making them well suited for our specific applications where balancing constraints may not be essential. Understanding their properties and complexities can also lead to optimal design choices in diverse scenarios. This was a small video giving an introduction or explaining the different scenarios in the dynamic hashing and data structures and also the left histories concept. Hope you understand the like the video. Thank you for watching.